Hello, sir. Good morning, sir.
Hi, good morning. Can you hear me?
Yeah, yes, sir. Yes, sir. It's audible. So within a few minutes, we will start the session, sir. The participants here to join. We wait for two
Yeah,
more
yeah.
minutes.
Sure, sure,
Yeah.
sure. No problem.
Thank you.
Rohit sir, shall we start the session?
Yeah, I'm ready to start
Yes, sir.
whenever you want me to start.
Yeah, yes. Good morning to all. I welcome you all for the FDP on Next Generation Key Trends, Challenges and Opportunities, which is organized by the Department of Computer Science and Applications. Today's topic is current trends and advancements in AR/VR industry. The session will be presented by Mr. Rohit Prakash Sir, Senior Optical Engineer, Avagan, San Mateo, California, USA. Now I call upon Dr. D. Shuganti Ma'am, Assistant Professor, MCA, to introduce our chief guest.
Thank you, ma'am. I, Dr. D. Shukanti, Assistant Professor in the Department of Computer Applications. I really happy to welcome to our today's chief guest, Mr. Rohit Prakash, Senior Optical Engineer, Avigant, San Mateo, California, USA. His background is in optical physics. He completed his undergraduate degree from Anna University in 2009. From 2009 to 2010, he did an internship in Apollo Hospitals to learn medical imaging. He was in Europe from 2010 to 2015, Switzerland, in Germany. He studied master's degree in biomedical engineering and then worked in the field of super resolution microscopy for biomedical applications. 2015 to 2017, he completed a master's in optical physics. 2017 until today work in AR/VR industry, currently working in Avigant in San Mateo, USA. Thank you, sir. Thank you so much for welcome this today's session. Over to you, sir.
Thank you very much for the introduction. I'm very happy to uh, share my thoughts and speak at this seminar. Uh, I don't know what the organizer's preference is, but I'd like to keep it interactive, so we don't have to like wait until the very end. If somebody has a question, I think we can. I'm comfortable if they want to ask a question in between. They're not going to interrupt my flow of thought or anything like that, because I've probably given this talk at least 5 times for in various different occasions. So it's no problem. It's more interesting if it's interactive. But if the participants' preference is to keep the questions for the very end, that's fine. That's fine with me too. All right, let's get started. I think this is day 5 of an exciting series of talks. Some of which I've heard reviews from other people, but I didn't really like tune in to listen. But here we go. So I'm going to share my experience in this AR/VR industry. Why I think that it's pretty exciting. We are at a very exciting stage where the technology is starting to pick up. Very interesting and innovative products are starting to come out, and this is basically this is a very good time to be in this industry. Of course, I'm going to say that because I am in that industry. But here we go. Not too much about me. Just I already had a pretty good introduction. So my background is in optical physics. That's been my interest, and I worked in a few different places. I've worked in Switzerland, I worked in Germany, and now I'm working in the US. My past experience basically ranges from microfabrication in the clean room for microfluidic devices, and some super resolution microscopy experience, and currently I'm in the augmented reality space. Right. So I wanted to keep this talk fairly general, covering a broad range of subjects. That is intentional, because I'm pretty sure that with these many participants, people from various different backgrounds are going to be participating. So we want to I want to give a chance for everybody to get a flavor of this talk, and also be able to like ask questions. Don't hesitate. There usually aren't any silly questions. Any question is usually an interesting question, but we are going to keep it technical, of course. So I thought I'll give a brief introduction of what this so hyped AR/VR field is about, how it evolved over the last. You'll be surprised. It probably has evolved over the last 80 plus years, probably 70. So the very just an interesting tidbit. One of the very first patents in this field was issued in 1958, way earlier than people would have imagined, right? So it's been around for a while, in like small pockets here and there, but now it's becoming fairly mainstream. People are starting to talk about it. Products are starting to come out. So it's gaining momentum. So of course we have to give a little bit of flavor about like if there is no money to be made in this industry, nobody's going to be interested. So I'm a technical person, but we have just one slide on the financial side of things. So I wanted to then give some insight about the state of the art in the hardware, the state of the art in software, where things stand, what's helping this industry gain these leaps and strides in progressing forward. Some crucial display technology enablers that are very central to this field, which we cannot do without. Why, of course, in this field, the end products are going to be finally it's going to be like a person who's going to wear this product and use it, right? So we also have quite a few like human-centric considerations while we are developing the product. Things like it cannot be like big and bulky, and cannot be ugly looking, which people don't want to use. So we'll get to that eventually. Some very interesting and active areas of research, which if you're interested in this field, you should probably check these out. So not only about the current state of the art, right? We are going to look a little bit into the future and like make educated guesses as what's going to be a good product. What does a mass adoptable product, right? Would anybody 25 years ago, would anybody have believed that almost everybody in this world would have a smartphone in your hand? 20 years earlier, nobody would have imagined this, right? But today it is a reality. So based on current trends and where technology stands, we'll also look into the future and try to see like what would make sense in a future product. What's going to make it as widely adopted like a cell phone? Or, yeah. So let's dive right in. I think it's going to be pretty interesting. I think I have about 45 to 50 minutes. I'll try to cover as much as I can. All right. When we say like augmented or virtual reality, most likely like people are imagining these headsets on our heads that we can like interact with. Some of you have even tried it. Some of you have not. Some of these products are starting to commercialize and become available in most parts of the world, including India. So basically, in short, any AR, VR, or like a mixed reality, augmented, virtual, or mixed reality, which means a combination of both. Those are just gadgets that help you interact with the virtual content, not only with the virtual content, but in some cases like the augmented reality, the real world is not occluded. For example, I can have an AR augmented reality device. I can be wearing a device like that while still giving this talk, being aware of my surroundings, and still be able to look at like virtual objects, like zoom in, make some animations, or like explain something in an audio visual manner instead of just like a 2D PowerPoint or something like that. We can give a truly immersive experience. So that's augmented reality. How is it different from virtual reality? Virtual reality is when the user doesn't have this. It's only an immersive experience into the virtual world. You don't get to interact with like real world objects here. So the user is typically like cut out from the real world. Yeah, obviously you can still have like your sensory responses, but in the virtual reality device, you're completely immersed in it without much awareness of the real world. Mixed reality, in my opinion, is basically a mode that enables the switching between augmented and virtual reality modes of operation. That's basically what most people refer to as mixed reality. A typical augmented reality headset might look like this. You might have heard this name. The company is called HoloLens. It's a subdivision of Microsoft, and this is one of their more recent products. Probably the HoloLens version 2. And I'm just going to show you a short video of if you were looking through an augmented reality product like this, what would be the nature of interaction, what you could and cannot do, and things like that, right? So here in this frame, the furniture and the sofa and the carpet, those are all real objects, right? And the pillows that you see in the corner. But what is virtual is all of these like coral and seaweed sort of structures. Those are overlaid onto the real world objects to make this augmented experience. So you're not completely cut out from reality, but it's augmented with virtual features. That's why we call it augmented reality. Yeah, this was something that we developed at my previous company called Magic Leap. We were very happy when it came out well. To be able to deliver a very good augmented reality experience. It's not only the hardware, not only the usability, not only the industrial design, comfort, things like that. It's a lot of things that need to come together to deliver a very enjoyable AR experience, right? You need to have the optics should be designed well. The display technology should be nice. The software pipeline should be nice. It shouldn't feel like laggy and shouldn't feel like the video is getting stuck, or the video doesn't have a good enough resolution, or something like that. So you got to have like good hardware, a good a good software, good firmware, meaning all the controls that integrate between the hardware and software. All of that needs to work together in tandem. But not only that, you got to be able to deliver really nice experiences through that augmented reality platform. So I just wanted to give you an example of. So in this example, we had designed our device. The name of the company was Magic Leap. So we had designed this wearable device, and what we want, the experience that we wanted to give a user is as if they have gone scuba diving under the ocean, and they're actually interacting with the corals and fishes and all the other like sea creatures like the sea turtles and the octopus that you saw, that you feel like you have a realistic interaction. We were the content designers who were designed the content to go on that device, they were even able to make it as realistic as if a fish is approaching you and you try to like touch it, the fish gets scared and like it swims away. It was that realistic of an experience. So we'll see what are the things that made an experience like this possible. So it's an example of a virtual reality device where you don't have uh, the the see-through feature where you can look at the real objects in the outside world. You're only looking at virtual content, virtual reality. All right. So we spoke earlier on that sometime in the late 1950s, one of the earliest patents was awarded in this field, which means somebody had thought about this way before all of this hype and surge that's happening in the industry, right? Almost like 60, 70 years before. So how did it evolve? Like most industries, it had an early proof of concept. Then came a big bulky device which didn't look anything like what the people who got the idea wanted it to look like. It was like big bulky. It could do like a few different things. Here's an example of how a personal computer looked way back in 1980s. Back in the 1980s, it evolved. Technology progressed. Things miniaturized. More computation and with more computation and display and memory and haptics and you name it, battery technology. everything had to evolve to make that computer on the left from the 1980s evolve into something that we carry in our pockets. We almost take it for granted, right? We don't truly stop and think about like how much computing power the smartphones that we have in our pockets have, and what are all the technological advances that had to happen to make it possible, right? That's a huge step. And it didn't happen overnight, clearly. It took 50 years. So this industry is going to be no different. You're going to see the technological growth, then it being implemented in a product, then people wanting to improve the product or improve the experience or make it smaller or make the battery last longer or make the display look sharper, crisper, right? Things like that. That's going to happen. It's an evolution. So here's sort of a timeline. Back in the 1800s, way before even the first patents, right, in this field, people were just looking through like stereoscopes and basically sort of a paper slide would be placed. You could see it. Like, then the next slide will be placed, and the next slide will be placed. And if you do it fast enough, it'll look like a movie, right? Basically, the stuff that we used to like draw in books and we flip through, and it looks as if that cartoon is moving. That's the exact same concept. Sometime in the 1960s, scientist Ivan Sutherland, he thought, okay, I'm going to take all the optical gadgets and light sources and display and whatever else, what have you, and build myself this funny looking jig. It's big, bulky, looks like a bug eye, but that was his concept of taking an image or a video that was being projected completely elsewhere and relay it to the eye, right? That was in the 1960s. In the 90s, Sony had their boom. They came out with this Nintendo Virtual Boy, had some, for considering the technology back in the 90s, had some pretty cool haptics and joysticks and sensors, and it was an okay experience. But then the later in 2010 to 2020 is really when the boom happened. Google Glass came out with their early products. A company called Vuzix came out with their initial products. Oculus, HTC, Microsoft, everybody was jumping on this bandwagon. Everybody was getting interested in this technology. Why exactly? Because they had seen the evolution of how the computers have shrunk into like a little smartphone that you can fit in your pockets, something that weighed several kilos and took up the space on a large desk like this, now fits in your pocket, right? So many of these companies obviously had visionaries. They had more information than was available to public, and they were able to foresee that somewhere down this evolutionary line, our smartphones are going to become feature complete, meaning there's nothing more that you can add on a smartphone. Just think about it. What is most big companies, I'm not going to name names, but what has most big companies done in the last few years, right? They went from one camera to two camera to three cameras to like one camera placed here, the other camera placed elsewhere. It's basically a sign of saturation, right? Smartphones have been feature complete for at least 5 to 7 years now. And big companies know that. They know that they don't have a viable product pushing smartphones anymore, right? So they wanted to come up with a certain technology that is able to do everything that a smartphone can do and deliver something more, right? An immersive experience, an audio visual experience, or a theater-like experience, or like the one that we saw, right? Like as if you were going scuba diving, right? Some other sort of immersive experience. So they saw this progression that PCs, personal computers, now fit in your pockets. If this very same trend continues, pretty soon the smartphones are going to become ubiquitous and pretty useless, right? It's hard to imagine now, but 7 to 10 years from now, I think smartphones are going to start being replaced because they have been feature complete and there's nothing more to add in them, right? That's what sparked this growth for the AR VR industry, and ever since it has picked up pace. So yeah, lots of technological advances had to happen for a device that used to look like this in the 1960s to very cool looking devices today. Things like this augmented reality headset from this company called Meta, or the HoloLens 2, or Magic Leap, things like this. Lots of developments had to happen, technological breakthroughs, literally. So, like I said, this is all predictive, like market projections. This is not a guarantee. Excuse me. You might hear different versions of this from different people, and they might have different opinions about it. So basically, what it is predicting is that in the next few years, the mobile phone industry is going to saturate because it's going to become feature complete. And right around that time, when multiple companies start feeling that they don't have a viable business selling smartphones, that's when the AR VR glasses are going to, augmented reality glasses specifically, they're going to start picking up. The sales are going to pick up, and the number of devices and the kinds of features available on these devices are all going to pick up. Like we discussed before, the progression of technology in certain display devices is very key to make this happen. So we'll go into what all these mean. LCOS means liquid crystal on silica. It's a certain kind of display that's a polarization sensitive display. DLP stands for digital light projection systems. Micro LEDs, LED stands for like light emitting diodes, or like light emitting. OLEDs are like organic LEDs. LCDs are like liquid crystal displays, so on and so forth. So it's basically sort of a color coded chart of how many million units different companies are going to be able to sell and what technology they are relying on. This is just a predictive forecast there. So the trend seems to show that most companies are going to either rely on a liquid crystal type display, or a digital light projection engine, right? That those take up amongst the biggest share in the mid 2020s, right? And as technology matures, most likely these are all predictions based on like emerging trends in these fields. The micro LED domain, which is actually a pretty exciting field, exciting display technology. That industry is going to mature. It's going to catch up to the rest, and it's also going to contribute like tens of millions of devices sold, or tens of millions of displays in these augmented reality headsets. So CAGR is sorry for all the acronyms. It's annual growth rate. So basically, cumulative annual growth rate. All right. We spoke about the technology. We sort of have an idea of like what all advancements need to happen to make it possible. But let's check in right now. What does the current trend look like? What are the technologies out there, right? Predominantly, think all the developments on the hardware side. I typically categorize it into like 3 or 4 major domains. One big contributor, primarily driven by the semiconductor industry, like the same industry like Intel and Qualcomm and all of these companies that make silicon chips that go on your phones, laptops, other electronic devices, things like that. The maturity of that industry also drove the micro and nano fabrication technologies for optical components, right? That was a big contributor. That was a big enabler in making these AR VR products available today. Um, another big factor are like small optoelectronic devices. By optoelectronic meaning part of the device has an optical functionality, and rest of the device behaves like any other electronic component. And miniaturization of all of these optoelectronic components was another major factor, and and one of the final contributors is um, investing money and research and brain power into looking at different display architectures, not sticking to the traditional LCD type display. People have investigated all sorts of different architectures like micro LEDs, liquid crystal panels, even lasers for illumination, right? All of these novel display architectures are pretty crucial there. So I consider these as the major drivers for development in this field from a hardware standpoint. And instead of want to make things a little bit interesting, so let's look at one such video where they sort of briefly go over the use case and show you one such example of how the HoloLens 2 came together. And apologize for the audio. I have not been able to get this audio to work. But it's pretty cool animation. So here are some like micro projection components, which they're just basically highlighting the fact that the electronics had to miniaturize, the optoelectronics had to miniaturize, the display, the overall display had to miniaturize as well. That's a MEMS scanning mirror. It's a pretty cool looking product. One of my favorites. And this is not a fake video. The motorbike is actually real. The guy is trying to like work on that motorbike, and he's getting all sorts of virtual assistants. The device is able to like scan the surrounding, pick up, look for different components, and like highlight to the person trying to fix the motorbike, in aiding the person to saying, okay, this is what you need to work on. So this wire has such and such functionality. This is this component of the engine and things like that. He's getting like real time cues as he's trying to fix the problem, or trying to get the motorbike to work again. This is one such. This is an example of this. This is one application. Quite a few companies have also employed augmented reality devices um, for medical use, meaning surgeons don't always need to practice on cadavers to say like hone their skills. They can even get a feel for the anatomy and the physiology of the human body uh, just by looking at virtual content and practicing some example surgeries with some haptic feedback. It's pretty cool actually. Yeah, here is an example where the surgeon is able to like visualize inside the human body and say if they are a cardiac surgeon, try to see like where the clot is and how to operate on it. Here is an example if somebody is trying to imagine a scene or like set up a background scene in a theater or art show. Yeah, we'll probably come back to the details once we have seen what this technology is about. Let's keep going. I'm probably short on time, so I don't want to take up too much time. Um, so let's keep going. So all right, so that was the hardware front. We all know that if there is this piece of hardware, it has to be controlled with some sort of software, right? We have gone are the days when we are all analog. Even our phones don't have like buttons anymore, right? So you need if the hardware is the skeleton, the software is the brain that has to control all of that, right? So there have been some major advancements in the field of software or computer science or you name it, algorithms, computer vision, AI. Different domains had to like come together to make this product possible, right? So first and foremost, improvements in like advanced simulation tools, right? If you had to start a design, you had to like start somewhere, right? So you'll have to start modeling it in a computer, look at what the performance is before we even go into the prototyping phase and make like say tens or 20 parts of this device or so 20 copies of this device, for example, right? So rigorous and advanced simulation tools are key, absolutely key. So are the algorithms and developing very robust computational methods. So things like if you think about it, how does the device know where you're looking or what you're gesturing or what you're trying to interact with? In that example where the guy was trying to repair the motorbike, right? How does the device know what he's trying to look at or what he's trying to work on, right? It needs to be able to recognize the human hands, understand gestures, understand where the hand is in 3D space. Is it approaching the motorbike? Is it going away from the motorbike? What part of the motorbike is that individual working on? Things like that. To determine all of that requires very robust computational methods, right? You, there are certain methods called SLAM, SLAM. It's called simultaneous localization and maximization. There are like there are a plethora of computational methods to determine all of this. Do the 3D mapping, establish what the 3D point cloud is, where is the human user with respect to a virtual or a real object, the device should be able to make that distinction. What is a virtual object and what is a real object? Be able to make that distinction and understand gestures, so understand where you are in this 3D space, right? So all that requires pretty intense algorithmic development. These are just some examples. These are some neural net and highly compressed image processing pipelines. These are just examples for algorithms and methods that have to be developed to make this possible. And all of this finally leads to real-time data processing, right? You cannot expect the virtual content to like move after the individual has like moved their hand or gestured. It cannot have a lag between the gesture and the virtual content recognition, right? So things have to happen in real time. So developing these real-time data processing pipelines is another major factor. Having a seamless experience, right? Having a nice experience. It shouldn't feel choppy or as if the videos stopping and starting and things like that. So real-time processing is key. All right. So we've talked about the skeleton, we've talked about the brain. Now time for the heart of this technology, right? Right at the very heart, there's some key display technologies and certain aspects or qualities that these display technologies need to have for it to become a viable solution. One is it should be pretty small, because remember, at the end of the day, we are trying to make a product that the person can wear on their head, not feel that it's extremely heavy, feel that it's compact, feel that it's functional, feel that they can have a prolonged use. So all of these factors are important if the product has to succeed. So it's got to be small volume, it's got to be manufacturable. It cannot be like a one-off research prototype that you can only make like 10 copies of in total, right? You need to be able to make hundreds of thousands of these. So it should be manufacturable. And it's got to be low power, because most of the times it's going to be working off of a battery and you don't want it to last just 15 minutes. You want it to at least last one full day, right? That you can put it for charge at the end of the day, right before you go to sleep or something like that. So it's got to be small, manufacturable, low power, low cost. One of the reasons the smartphones have become so widely adopted is because they were introduced at a very reasonable price. That's what most people think, at least to be able to go out and buy it. Good brightness. You should be able to use the device in dark lighting as well as bright conditions, and good image quality, right? So let's see what checks all of these boxes. What satisfies all of these criteria to make it a viable display technology for the AR/VR market. One of these are micro LEDs. We spoke about it earlier. I'm not going to deep dive into the technology. So basically, what these micro LEDs are is a small array of very fine pixels, where the pixels themselves are emitting light, right? This is a very unique technology. LEDs have been around for a very long time, but LEDs at this size scale is a completely different ballgame, right? It's the sheer size that it's so small is a big enabling factor. So these are pretty compact and these are pretty fast, so they are super responsive. You can have you can stream video at 60 hertz without things getting stuck or feeling slow or interrupted. The video will look smooth and seamless, so it can operate at close to like 6x of what our eyes and brain can comprehend. So it can go almost like 6 to 10x faster. These are pretty bright, so checks the box of being able to work in different lighting conditions. But the main drawback is Scaling them from the typical LED size to the micro LED architecture has not been easy. That's why when we saw the graph earlier, this technology is not predicted to catch up until the late 2020s or early 2030s. This technology is still maturing, right? It's one of the big drawbacks. Another big drawback is these devices heat up really quickly. So thermal management is a big problem. So it is a viable display technology, but possibly for the future, right? Another is laser beam scanning. We just saw that example in that video where there are red, green, and blue lasers that get raster scanned to create like a video stream sort of experience. So basically, it's just a single point beam that gets raster scanned across your eye to make it look like a full-blown video, right? So that's why it's called laser beam scanning. These are pretty compact, high contrast, high brightness, but making these components are pretty complex. It's not a day-to-day affair, and these have other problems. There are safety concerns, coherent artifact mitigation, things like that. So it has its own problems. Looks like this is also a prospect for the future, given all these drawbacks. So the next really promising technology, right, are digital micromirror devices or DMDs. These are pretty bright, not self-emissive, meaning you need a separate light source to illuminate these panels to get an image out of it, right? These are not self-emissive, but these are highly reflective, very bright display technologies. Contrast is fairly good, works pretty fast, so no problem about video streaming. But some of the major drawbacks here are power consumption. How much power these DMDs draw for their basic functioning, that is a big drawback. Not only that, it's very few manufacturers in this world. In fact, there are only two major DMD manufacturers in this world. So, which means they almost have they have a big share of the market, and so the cost is pretty high. They're not going to bring the cost down anytime soon. So is the size. These are fairly bulky. That brings us to the last display technology, right? Liquid crystal on silica. Most mature, high brightness is possible, has been around for a long time. So the cost is very affordable, pretty good contrast, very widely adopted. So it's very scalable and fairly low power consumption. The only minor drawback is the back plane size. Basically, it's not the display, it's all the electronics that go behind the display to control and drive the display, right? People are actively working on it to bring that size down. So looks like from all of these bright prospects, LCOS is going to be the near-term winner. We don't know what the long-term, what the 10-year market looks like, but near-term, it looks like the LCOS panels are going to be widely adopted and used. All right, so we have covered different aspects. We have covered the hardware, software, and the display component that goes together. But since the end user is a human person, there are very human-centric design considerations. Let's take a look at a few. Right? For example, the image quality has to be pretty good. It cannot be blurry or fuzzy. That's not going to give a good immersive AR experience, right? So the image quality has to be good. That's first and foremost. It should have a large enough field of view. You'll be surprised at what the field of view of our eyeball is. Try probably after this call. Probably try doing this experiment. Try standing right against a wall and having your hand right against the wall. Like try moving your fingers, or you can even have somebody place their hand so that you don't know whether they're moving their fingers or not. and you can still see some movement in your peripheral vision, which means your field of view in the horizontal direction is larger than 180 degrees. In fact, it's closer to 200 degrees. That's what enables you to like stand against a wall. You can have somebody else place their hand against the wall, and when they move their fingers, you can still see this movement in the peripheral vision, which means that's a very wide field of view, 180 degrees plus, and the vertical direction is almost 140 degrees. That's a pretty wide field of view, right? So we need these devices to sort of match up to these large fields of view, right? There are different use cases for different subsections, but you need to have a good usable field of view, right? That's very key. Size is key because you need to be able to wear it 5 to 6 hours a day if required and still not have the discomfort, right? Weight is another big factor for the very same reason. Cost for mass adoption, right? If this has to reach the masses, it has to be at the right price point. Comfort is another big factor. It's got to be ergonomically designed so that the weight is evenly distributed. It's not just all the load on your ears or all the load on your nose or all the load like elsewhere back at the back of the head or something like that. Right? It's got to be nicely ergonomically designed. Of course, it's got to be stylish. If it isn't stylish, people are not going to buy it or use it, right? Why do people buy? Anyway. Yeah, it's got to be stylish and it's got to be functional. Why would you just buy an expensive piece of gadget if it doesn't serve the purpose, right? So you need to consider all of these factors while designing an augmented reality product with the end user in mind. That's what I call human-centric design. So let's look at some examples, right? All right. We saw some of these technologies. We discussed these previously, right? Compactness versus field of view, right? It's addressing the field of view and the size aspect. Let's see. Fantastic. So this chart over here, CC here is cubic centimeters. So basically, this is it's just a funny little thing we say in the augmented reality space. If you can design a light engine that's smaller than a sugar cube, then you won the market. That's sort of the funny standard. So here's a comparative chart where it's cubic centimeters, basically volume on the y-axis and field of view on the x-axis, right? This is taken from an SPIE Tech Talk in 2021 from the German company called SRM. They make LEDs and lasers in all sizes and shapes, also for the AR/VR industry. And their prediction back in 2021 was if you have to reach this lofty goal of fitting a light engine inside 1 cc, laser beam scanning is the only option. That's the way to go. That was their prediction, right? That didn't hold true. That assumption was broken at some point. We're proud to say that we were part of that technological breakthrough. We're not here to brag anyway. So these are some human-centric design factors that anybody who's working in this domain who wants to make a viable product has to consider to make a successful product. So right in there with the LEDs and with an LED and an LCOS display, basically this combination that OSRAM was predicting that can never breach the 1 cubic centimeter mark. We broke that with the LED and the LCOS technology, right? Right then and there was when this assumption about this graph was broken. We came out with two different designs, 30-degree and 50-degree field of view. 30 degrees for basic information display and pop-ups like what you get on a phone, but instead of a phone, have a completely hands-free experience. And the 50-degree field of view light engine for a slightly more immersive experience. So this is the compact light engine that we designed back in 2021. And like we were discussing, right? It's got to look comfortable. It's got to be comfortable. It's got to look stylish, right? These are just an example device from this company called Snap. Another example of if it looks like a usual pair of glasses with added functionality, more people are likely to wear it on their faces, right? If they don't feel comfortable wearing this on their face, they're not going to. This product is not going to pick up. Just another example of when we used our design in a normal pair of glasses, and this is how it looks. Fairly proprietary. Please do not distribute or reuse this anywhere. Then let's look at some very interesting and active areas of research that's making all of this progress possible. There are a multitude of technologies that come together to make it possible, right? On a headset like this, on a head-mounted display like this, there are numerous sensors, sometimes up to like 15 to 20 cameras and sensors, understanding where you are in this world, like understanding what the head poses, tracking your eyes to understand where the person is looking, so that you can display the content at the right location, right? There's sensors, there's computer vision involved, there is 3D mapping involved, there are developments on the hardware front, on the optics front, on the fabrication front, plethora of things that need to come together, right? But some major active areas of research to make this product more viable and mass adopted, in my humble opinion, it's low power, longer lasting batteries. So working on like low power systems, it has to all of these subsystems that you see on the screen, they need to be able to like interact with each other. Everything is one unified AR environment, right? One unified device. They need to have a seamless integration at the system level. It needs to be able to do like real-time 3D data processing, so that it can capture all like humongous amount of data coming into the system and process it in real time. It's got to have a sleek, nice eyeglasses like form factor, and it's got to be able to make it in large volumes in a cost-effective manner. So these are some pretty active areas of research to make all of this possible. There are a few more very interesting ones. This is called. This is an example of a foveated display. If you talk to somebody who's a vision scientist, they will tell you that your eye comprises of a larger field sensory response on the retina, right? Where it's fairly low resolution, but all it's meant to do is to sense whether there is some motion in your peripheral vision or not. Some people call it peripheral vision, some people call it field vision. If you ever had glaucoma, you might have done the field vision test, right? And you're looking at a screen and like different portion of the screen lights up and you're able to like either pick it up or not. So that's your sense, that's your visual field. And within that field is a high resolution portion. For example, if you're reading text or reading a text on a book, or looking at your phone and reading a message, You're directly looking using only the high resolution portion of your eye. That's called the phobia, right? So a big and very interesting active research is going on to be able to make these AR displays with this fusion in resolution, right? Where there is a high resolution foveated component that moves along with your eye and tracks where your eye is looking, so that you can have like high resolution information wherever you're looking, and lower resolution field information. That's a major active area of research I find very interesting. um, it's not only interesting, but it helps save a lot of computing and display power, because this combined resolution display architecture helps reduce the pixel count on your display, whatever be it an LCOS type display or a DLP or a micro LED. It helps bring the pixel count down. That means lower power, cost, manufacturability, and smaller uh, and power efficient, right? They're able to bring the number of pixels down and still preserve the same resolution, right? So that's foveation technology, and this is something very proprietary to Avagant. This is our intellectual property. Uh, it's one of the methods. So this cartoon that you see on the left, where the eye is moving and the display zone is moving along with it, the high resolution region is moving along with the eye. That's made possible by this high speed proprietary design. And it's a 2D mirror that can scan both in X and in Y, and it tracks where the eyeball is and displays high resolution content there. Not only that, there are some very interesting developments right around the corner. Those are foveation. So the foveation has an optical design component to it, a software component to it, so that it can track the eye and control understand where the person is looking, and display the high resolution content exactly in the foveated region, and move along with your eyeball within your larger field of view, right? That's made possible by very custom software that some companies, including Avagant, have developed. High speed, low power eye tracking. You got to be able to track the human eye movement in real time. Not as easy as you think it might be, right? So an example of such an optical system would contain a waveguide. A waveguide is nothing but a method to replicate what you see on the display and bring it to your eye like a TV screen. It's got a micro display. We have seen several different flavors of it, several different types working differently, all trying to achieve the same function, and the proprietary steering mirror. We have our own software pipeline to make all of this possible. And then there are low power eye tracking devices that go on the frame of the wearable glasses to be able to make all of this possible. So all of these have to come together to make a foveated display possible. That's an eye tracking camera and an optical flow sensor, basically to understand where the eye saccades. Saccade just means to smoothly move from like one portion of your field of view to the other. As the eye saccades through your field of view, the eye tracking camera picks it up and tells the micro display, tells the steering mirror to steer the high resolution portion of the micro display to that portion of the field of view where the end user is looking. So that's that. And what else? You probably heard of this word called light field technology. So when you're looking at the outside world, right? there are contents that line up at all different depth planes. You could be looking at something very close, like reading a newspaper, or looking at something really far. For example, you might be waiting at a bus stop, looking really far away for the approaching bus, trying to understand whether that's the one that you need to take or not. So your eye is able to adapt between a wide range of depth planes, right? Right from like arm's length newspaper all the way out to like several meters away to look at an approaching vehicle, for example, right? So this display engine needs to be able to um, work along with your eye at different depth planes. That's called light field technology. I'll be more than happy to like take some questions offline after the talk about this. We can spend a full week talking about light field technology. Very exciting, something right around the corner. Hopefully, it's going to be engineered into some of the future augmented reality devices, right? And both of these together, the foveation technology plus the light field together will enable very seamless, natural feeling focus as well as resolution, right? Because our eye has very high resolution, but in a very small portion of the field of view. Rest of it is peripheral vision or field vision, where it's just fuzzy to detect movement, and the eye can focus at multiple different depth planes, and the device has got to be able to like work along with it. So all these technologies hopefully will come together in the future, make a very compelling AR product. Foveation is the only realistic path forward. That's not because my company is involved in that research. That's because there's a physics bottleneck to go any further. We cannot reach the resolution of the human eye with current pixel densities of current displays. The only way forward is foveation. Right? And light field, as we discussed, is also key to switch between the near and far focal planes. This combination is, I assume, is going to deliver a truly immersive experience. All right, just glossing over some quick applications, some applications that have already been put to use, and some have been envisioned, are audio-visual education, gaming, of course. Who doesn't like a good augmented reality or a video game, right? Simulation and training. It could be for pilots. It could be for doctors. It could be for surgeons. It could be for astronauts. You name it. Any sort of haptic feedback, audio visual training, right? Yeah, stuff like architectural walkthroughs. If you're imagining, if you'd like to build a house and plan for the interior design, you have the possibility of this virtually displaying a few different like architectural layouts and seeing if the person who's going to build and own that property likes it or not, and things like that, right? There are some like medical use cases. All right, if after this talk you just want to forget about it, well and good. But if this talk made you curious, you can check out some of these knowledge bases, where there's some very interesting content all the way from beginning foundation level information, like early stage beginner level information, all the way up to very sophisticated AR VR architectures, and how people envision making them. You have entire spectrum of information. Stanford and MIT are pretty good resources. There are also universities in India that have their own design labs, and some very interesting companies here. I intentionally left the name of my company out. I didn't want to make this feel like a marketing talk. This is a tech talk. Okay. So there's some very good resources out there. You guys should check it out if you're interested in this field. Yeah. Exciting developments over the last 20 years. Very interesting applications. Many companies are pursuing different aspects of this, different strengths of the AR VR industry, and envisioning new applications. Energy efficiency is definitely something that we need to work on. If we need a wireless battery operated device to last one full day, cost and scalability are other very important factors. And before mass adopting any new technology like this, I highly recommend that whatever the country it's being implemented in, has to meet the local health and safety guidelines before it can become a consumer product. That is key, because the end user is a human individual, right? We got to make sure that it's okay to mass manufacture these devices and be able to have extended hours of usage and still be okay. With that, I'll conclude my talk, and I will open the floor for some questions. If people are still with me and would like to ask questions, let's go for it.
Now the forum is open for participants to interact with our chief guest and ask your queries.
If it helps, I can go back to any of the slides that I presented to help aid some questions, or I'll take the silence for either you guys really liked it, or you guys probably went right by and didn't notice. Either one is fine.
Hello, sir. I'm Dr. Pragya from Nagpur. Sir, which
Pragya.
software is used for AR and VR? Which software we have to use?
For different aspects of AR, VR, different softwares are used. For example, for making the for creating the virtual content, people often use Unity or C#, or sometimes for the FPGA, for the control of the electronics and things like that. For more hardware and architectural work, so, people tend to use like C# and other more fundamental languages. But for creating very immersive content, Unity is a very popular software. There are a couple of others. There are some very interesting
So, according to you, which one is best?
there's no best or worst. Like, different aspects of the software are meant for different use cases. For example, you can't use the same software used for creating the 3D content to control all the electronic gadgets, right, behind the scenes. Control the display. There are different levels of like software and firmware. Typically C#, sometimes other options. There are some JavaScript based programs that work quite well too. But different softwares have different functionalities. Some are used to create the content, some are used to display the content, some are used to control the electronics, and they all serve different purposes.
The application to application, it varies.
artificial
No,
intelligence இது பண்ணுவாங்களே இப்பெல்லாம் யூஸ்
sure,
பண்றாங்கல்ல
yeah.
இந்த அமேசான் இதெல்லாம் யூஸ் பண்றாங்கல்ல எனது ஷாப்பிங்ல எல்லாம் வந்து நம்ம ட்ரையல் ரூம் ட்ரெஸ் எல்லாம் அவ்வளவு போட்டதெல்லாம் ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் தானே கண்டிப்பா கண்டிப்பா இருக்குல்ல
Sure, yeah. So different pieces of software serve different purposes. Even within a single device, it's not unusual for, say, a game developer to use a certain software, whereas the electrical engineer to use a different software to control the electronics, right? Or the firmware engineer to use a different piece of software. That's actually a very good question. Got me thinking.
Thank you, sir. Really nice session, sir, and very informative.
Thank you very much. Are there any other questions? Feel free. Don't have to be shy. I'm the only person turning the video on, so. Okay, let me ask you guys a question. Do you think that any one of you would be interested in checking out an AR or a VR headset? I actually have one of each. I was just interested in seeing would anybody who attended this talk, would you be interested in checking out what it feels to like have an augmented reality headset to say like play a game or like read emails, or for example see a video on YouTube or listen to some songs on Spotify, or listen to a radio station or anything like that. Does it make you guys curious, or are you guys even interested in checking out this technology?
Yes, sir.
Hello.
Hello, sir.
Hello, Prema.
Hello, sir. Yeah, we are interested, sir. But how can it is possible, sir?
Maybe I'll try to make it happen when I come to India. We can try to arrange a demo on site at the SRM campus, for example. We can think of something like that, possibly in the November-December timeframe, something like that.
Okay, sure, sir. I also interested, sir.
Sorry, I wasn't able to track who spoke. Was it? Am I talking to Prema? Yeah, if people are hesitant to ask a question out loud, we can even let me stop the screen share. And we can even switch over to the chat to type in your questions if you're interested.
Yes, dear participants, do you have any queries? You please unmute and ask, or else kindly post your queries in the chat window.
Thank you very much. I think somebody has asked. AR devices to experience AR. Yes, I do. I do mean like AR devices. Maybe maybe I can. Let's see if this even works. This is something that I worked on in my previous company. Called a legacy edition of Magic Leap. I don't know if the battery is fully charged, so I don't know if it's going to work, but let's give it a shot. So, like to see a live demo for yourself. You might have to wait until December, but if you just want to see me do it, you can try it out. So here is the Magic Leap device that we built in 2017, quite some time ago, quite some time back, probably 2018 actually. So if everybody can see it, are you guys still able to see me? See the video? All right, I guess you can. So here is the battery operated belt pack. Once you press, if it had the battery, it would turn on. So it looks like it's not charged. All right. So here's the battery that goes in your belt pack like this. For example, in your pocket, right? And there are some really cool tracking devices. So here are two. Here are a couple of infrared cameras that scan the outside world and map the outside world to understand what's going on. Here is a 6 DOF sensor. 6 DOF means 6 degrees of freedom, basically movement in X, Y, or Z, and rotation about all of those axes. Why do we need those degrees of freedom? So basically, you take this device, go around your head, and wear it on top of your prescription glasses that you're wearing, right? You wear it like this, but most of the controls are done using a handheld joystick like this, right? It has so you wear it like this, you can watch a video, you can listen to music, you can interact with virtual content, you can play a video game if you like, you can do all sorts of virtual stuff. So here is what's equivalent to a mouse click. You see a little button over here, that's a mouse click. Here is the equivalent to a right click and a double click, right? Here is a touchpad. This entire soft surface over here is a touchpad that you can use to like scroll. And the position of this gadget with respect to the 6 DOF tells the instrument where the person is pointing. If it's not able to track your eyes, which it will, if it is not able to track your eyes and your hands simultaneously, this 6 DOF is meant to like aid it to understand where the person is pointing and where the person is looking. So this is an example device. It would have been great if it were fully charged and I was able to show you guys a demo, but unfortunately not. Maybe next time. So this is how it looks from the side. It's pretty light. It weighs only about like 130 grams. Not very light, not as light as your glasses, but fairly light, under 200 grams. And here is the equivalent of a mouse and an input device. And at the moment, it's tethered, meaning it's connected by wire to this battery that latches on to your belt. So it's called a belt pack. That's how an example device looks. And this is being made much more advanced over the last few years. So hopefully that gives you an idea of how a typical AR device looks like. And if it were possible, we can probably make an in-person session possible probably towards the end of the year when I visit India. I usually make it a point to come back once a year at least. So, all right. Hopefully everybody enjoyed the talk, and we are finishing right about on time. There are no more questions. Thank you everybody for joining this talk. Thank you for inviting.
So dear participants, do you have any queries or do you want to share anything? So no more queries from participants. Shall we wind up the session, sir?
Yeah, somebody here has, so I'll just type it into the chat box. You can reach out with any questions.
Hello.
Yeah. Hello. Yeah, I can hear you.
Good morning. It was very nice session, sir. I'm having I'm not really having a doubt, but if there is any sort of thing like ICT tools in AR VR, sir, we find many sort of games and all in online stores.
Okay.
Is there any tool for taking classes or like that, ICT tools in the mode of AR? Yeah.
ICT meaning learning over the internet. You just want to
Yes,
learn more about this field.
Yes, sir. Like if we want to teach a topic to our students, how we can use these kind of tools? Is there any tool?
Oh, I see. Yes, different platforms have their own teaching tools. So let me repeat your question just to make sure that I understand. Are you wanting to learn more about this field, or would you like to use this platform as a teaching platform? So what exactly is the question?
The platform for teaching purposes.
Oh, for teaching purposes. Okay. So these AR VR devices have come with their own software, just like your smartphone. People develop apps for it. There are video apps. There are different kinds of tutorials. There are different kinds of environments that you can create in the video. And something very interesting that many companies are working on, and two of them have been quite successful in doing it. One is the HoloLens team from Microsoft, and the other is the Magic Leap team. Both of them have been successful in implementing a multi-device interaction, meaning if you are wearing a device and I am wearing a device and we are looking at the same audio visual content, like streaming a video or looking at something, we are both able to interact with the virtual content and discuss. So that is possible. That's your question. Different platforms have different softwares, and they have their own developers, app developers, who develop based on what the market is asking for. And there are very, very interesting teaching tools too. I hope that answers your question. Somebody in the forum has also raised their hand for a question, I believe. Can you specify the basic tools and softwares to execute labs? Lavanya, what do you mean by that? You want to teach a lab and you want to understand what tools and softwares exist to be able to do that? Is that the question, Lavanya M? Well, to answer this very generically, there are teaching tools, there are interactive tools. You got to make sure that the hardware and the software supports it. So far, only two companies have been very successful. There is a third company which they don't want me to reveal the name, so I'm not going to. But this is work in progress, and you can see, you can probably expect it in the next year or so. So they're planning to launch the product in 2023, most likely globally, which means it will be available in India. And we can keep in touch. We can form a forum if people are interested about the hardware tools, software tools, or teaching tools, whatever it is, right? Um, we can keep in touch and keep each other informed. Short answer is there are two companies at the moment who offer it, and it's possible if you have those devices, right? Can be any form of teaching, any form of like audio visual teaching. They've used it in for training surgeons and so on, right? So I'm sure there should be a way of teaching students. Somebody in the audience raised their hand. I wasn't able to figure out who it was. Oh, Dr. Ranjit Singh. Sir, do you have a question? See a hand raised, but no question.
Sir, you unmute and ask your query, sir. Dr. Ranjit Singh, sir.
Is he able to unmute, or should I have to unmute? Everybody has the ability to unmute themselves, right?
Yeah.
All right, while we are waiting for the question, somebody pointed out a couple of interesting things. There are these apps called Aurasma, AURASMA, and DACRI Studios. They seem to be very popular in creating like AR teaching content and AR apps. I've heard of this company actually, DACRI Studios. I can type it into the chat box if people are interested. Let's see. This app developer, this company is called Aurasma DACRI Studios. Quiver. Yeah. Augmented reality, that. These seem to be popular app development groups or companies who are working for developing apps specifically for the augmented reality market. So hopefully that answers some of the questions, and it would have been fantastic if we were able to have this talk in person, where I could have given you all a demo of an augmented and a virtual reality device. That would have been very interesting, I'm sure. Okay, there are no more questions.
Dear participants,
Thank you all
any
for
more
attending.
queries? Participants, do you have any queries?
Dhanama, you go ahead, ma'am. No more queries.
Yeah, okay, ma'am, sure. The session is very useful and informative for the participants. We are thankful for sharing your experience in AR and VR industry. We are really enlightened with your knowledge and presence. You have clearly explained about AR, VR, mixed reality, technology growth, trend line, and also displayed the growth of AR, VR technology from small to large volume. You have specified research directions on augmented reality. The session is very useful for us. Once again, I thank for spending your valuable time with us to share valuable information. We are looking forward your presence for the upcoming events. Thank you so much, sir.
Thank you very much. Thank you for inviting me. I had just as much fun as you all. Can hopefully we'll meet again next time.
Thank you, sir.
Take care. Have a good day.
Dear participants, feedback link posted in the chat box. So please kindly complete